Let's go, let's go. All right. So here we are. We got the K1 still in the same spot. Didn't touch it at all. Basically, we're picking exactly up where we left off at. So let me get these cameras in here so you guys can get a look at what I'm doing. Let's see. Nothing. I don't know if you can see over that. Maybe see from the top. Hopefully you can see in there. And we'll get this one in at the top as well. Alright. Alright, so this is where we left off. I don't know if you can see that. It's basically nothing in there. See if I can get that focused. Maybe. Alright, so there's nothing in there. It's still taking on apart. I'm just really hoping that I remember how to put this thing back together. I have somewhat of an idea, but I'm not 100% sure, so you guys are gonna have to bear with me. Yeah, because I don't even know where that goes. I believe it goes there, goes here. Okay. Does that hold that down? Maybe. Alright. So we'll just be trying to reverse and play back along and see what we got going on. Alright, so I took out some screws, if you can see on this side. Took out some screws over here that need to go back in. That was totally unnecessary, and that were these small ones. So let me get those back in there. It's the reason why it's good to just pick up and do things immediately when you're ready to go, so we don't have to play the game of why am I left with 5 screws and everything's back together. Alright, so I remember them being small screws. Here we go. So let's get started. Let me hit record on this. Record. Alright, so is that the first one? Does it go there? Or does it go here? That's definitely not it. So it goes down here somewhere. It obviously doesn't go there. That short screw goes there. Okay. No, feels like a force or something. Okay. That's in there. Oh no, that's tight. Maybe that has something to do with it. Still tight. It's just because it's off. Alright, we got the other side to put in there. There's one right here. See that? Hold on, I'll show you how to tighten it. Oh yeah, they definitely have something to do with tension. Once I put them in, right here is a screw right here. Let's see if I can get you any closer. See, there's one right here. There's one right here, and there's another one on the other side. When I put those both in, I got a lot of tension on here, so I'm pretty sure they have to do maybe with the way that it grips on the linear rods. So what I'm doing now is just gonna loosen that up some. If I can get in there. Oh yeah, nah. That's about. Or maybe it could just be a lot of tension in there. I'm feeling like every time I tighten these things up, there's some tension in there. We'll see once we get this thing back on. But okay. All right, next step, get this heat sink out. All right, this is another ceramic heat block for the actual. I forgot I had this one. I'm sorry, I forgot I had this. I could have put that on that when I fixed the when I originally fixed the Ender 3 Pro, because I used the Sprite extruder on that. I had a ceramic heat block that I could have put on here, but we'll do that later. We'll put it back on this one and install it back on the other one. The other one's running perfectly fine, but that's just an accessory. Anyway, this is the kit. Didn't open anything yet. So you got your washer, little washer in there, your wrench, of course. You got your heat block. So now see, this right here will allow you to change the nozzle no matter what the temperature. So it can be cool. You can take the nozzle out, put a new one in. This is the nozzle already installed in it, so we really don't need to do anything but put this back into place. So let's do that. All right, so I remember how this went in here. Okay, so it goes like this. So it goes inside. There's a hole right here. See if I can get you guys closer, or maybe turn the printer your way. You guys come in the printer with me. All right. So there's a hole right here. We're going to slide this right into that hole. Trying to get these wires correct. So we'll slide this right into that hole. Trying to do this so that I am not blocking the camera. So you see this metal going into the actual hole. That's where the filament will feed through into it. So it's right into place just like that. But okay, I was just making sure that that still had the silicone thing on it. All right, so there it is. That goes right into place like that. What we got to do now is just remember what screws went where. So these are small. Maybe they're these. I'm hoping. I just made my little wrench disappear. I believe that's the right size. I'm going to use a hex 2.5. There we go. Alright, this goes here. I'm hoping I got the right ones going on, y'all. I don't remember. Okay. So the heat sink is back in there. Now to replace the, was it the motherboard? I remember the screws on the motherboard there. I know where I got them. This is actually going to sit like this. Is this fan on that side or the other side? So that's the heat sink fan. Could have swore that fan was on. So this is going to actually sit like that. So let's get this screw ready to go through so that it's holding the fan. 2 top silver screws. M3s. More than likely, that's what all of these are running through, M3s. Yep. There's a bottom screw. Where did that go? That's the top one. And there's a bottom one. For what though? So this right here is the Creality extruder with the orbiter style motor. That's going to be put on top right here, and the motherboard will go right in front on here. The only thing that I'm a bit confused about, there is a there's two screws. If you look at this motherboard, there's a screw here. Let's see if I can get it without falling out. There's one here and there's one here. They both go into these two holes right here. Then you got a bottom one. It's the one I'm a bit confused about. Am I missing something to attach to it? Just want to make sure I'm good before I actually start putting things back and they're not where they're supposed to be. So I'm gonna go ahead with it. If I forget something, then I'll actually just take it apart and do it. But I am gonna take this out, the extruder motor, and just remember where it's at. Keep note of where it's at. So I took it out. It's right there in the middle. This might be too big. The hex that I'm using very much was. Get that in there. Tighten it up, leave it loose, not too tight. Here's the second one. Get that through the fan, make sure it's going through that fan for the heat block. See, now we're bunched up in the corner. Take this out. Take this one out too. I'm sorry, y'all. I'm gonna give y'all another camera angle. Hopefully you can see from here. I'm gonna take this out. Put it in straight like that. I'm lined up good. Put you in there now. So there is another thing here. I just don't know what it attaches to. Tight. All right. It was a bottom. I don't know if And it was this black screw right here. Remember that, but I just don't know where it goes. It was there, but what does it connect to? Unless I'm missing something. I don't see me missing anything. Go into the old heatsink or something. I don't know if you guys can see what I'm talking about. There's a screw that went in through this part of the PC board on the PCB board on the hot end. It went in here, but it's constantly spinning. I just don't know what it connects to. Let's see if there's anything. It's obviously in something. Alright. Alright, so that's cool. That's tightened up. Let's connect some of these wires. So our hot end, get this other camera. So you can see what I'm talking about. Maybe, maybe not. Trying to get this tightened, y'all. Give me 1 second. Just bear with me. Alright. So we'll connect some of these wires. This right here. This right here should be. Let me see what this label. Okay, so this is the hot end wire. This is the heat for the hot end. This right here is the thermostat. Like we said, we put our extruder motor right there. And what else do we have in here? And our fan needs to plug in as well. So right now we're gonna install the extruder. The extruder will go here. I'm gonna make sure that the silicone slides over the new nozzle that's installed. There is silicone. I mean, the nozzle is right here. We want this we want this to slide over this actual metal nozzle that was just installed. That's what I'm trying to do now. Bent. Up. Maybe what we could do to make it easier is take this off, install it on the metal first, so we can find out what's going on. We may have to burrow this open a little bit more. See if we can do that. If I can get that in there. I got my hand in the way. Alright. So if I can get that in there, make that bigger a little bit. Twist it. Alright. That hole a little bigger. And now install it in there. It's not fitting. And I know if I just install this, there's potential that it can miss it without that in there. But as I'm looking down here too, it might not even be able to fit down the hole even once it fits on top of the nozzle. So it may be meant for it to go directly into the extruder. So what I'm gonna do to try that out is I'm just gonna install this without it. Just like so. Get a piece of filament. And see, does it go in there smoothly? And it does. So I'm gonna just leave that part off. Not gonna let it cause me any stress. So we'll install our pieces back on, which I honestly think I used the wrong screw for the side, so I'm gonna take those out. Oh no, here they go. These are them. Take that out. It's the wrong one. Okay. These M3s go in here. All right. Here. Put that in there. And then last but not least, this one goes right here. Tighten these all up now. Okay, we got that. Let's find out if these go here. So I got some extra screws that are longer, and I have no clue where they go. Okay, I know where they go. Never mind. That's gonna go here. That lines up there. So we got a piece we gotta put on. I'm pretty sure that's where this goes. It looks like it. So these ones are spring screws. Got springs on it. It's to hold that what wire is that? The wire going from the PCB board to the hard drive. It's It's to hold this down into place. And it's spring loaded so that it doesn't put too much pressure. It puts enough pressure, but it's not like breaking pressure on top of the wire. So what we're going to do is we're going to put the springs in here. Okay. And this is how it goes now. Now I'm missing something. It definitely don't go in there crooked like that. Alright. What am I missing? Because something was supposed to be on there spring loaded. And I'm pretty sure I thought it was this. Alright. Where's the front at? This is the front. Front goes on like that, drops, but there is something right here. It is this. I'm just forgetting how it went on. Alright. Was it crooked? I can't imagine this thing was installed crooked like this. That looks about right. Was it like this? Alright, y'all. We'll see. I don't see any other part, and I remember pulling this off. I just don't remember if it was crooked. So here's what we can do. We are going to go through some of this video. What I'm doing right now is just looking through my my video playback, because I did record that session. I think I want to group, because I did record that, what we actually did. I need to find out so that's not an option right now. Okay, no worries. We're just gonna put this on crooked, y'all. I mean, and it definitely wasn't on crooked. Here we go. It was just pressure on there. This had pressure, and these screws were on, and this plate was on like this. There we go. There we go. See, sometimes my brain works. I don't know if it was these screws. Let me find out if that's the case. If it was these screws, or was it the ones that dig through plastic? It looks like the ones that dig through plastic. Yeah, I'm pretty sure it was the ones that dig through plastic, and these are on the side. These go on the side. I'm hoping, people. I'm hoping. Definitely was these screws. I'm thinking they went through get this closer to you guys. I'm thinking it went through the springs. I just remember springs were in those holes. Wasn't necessary screws going through the spring, so that's cool. Tighten this one up now. Boom. And there we go. And these screws right here, these longer screws, I believe they go in here on the sides. If you can see, there's a small hole right here. I believe those screws might go in there. And they sure do. And it's another one, same exact spot on the other side. I don't think you can see it from this angle, but trust me, it's over here. And there we go. Now all we have to do is connect the wire ducts now. So, as we remember, this is, can't see, I'm gonna show you. This wire right here is the extruder wire. Goes here. Alright, it is in place. Okay. This right here. It's 220, it's the iron wire. Connects. See, can I spin this? One connects. Make sure the bottom. Alright, and one connects down here. See, it's a smaller one. Changed this hot than before. It's always tough getting this wire. It's like right under. Probably good to have a set of tweezers on hand for this. Oh. Instead of these big sausage fingers. Oh. All right, let me see if I got a pair. Please don't do this. Use tweezers. Oh no, I got some. I got some needle noses. I was about to use let me drop this real quick. I got grease on here. This is gonna make me upset. It's about to use some filament nippers. Could cut the wire. So can I get it? Remember, don't force anything when you do this type of stuff. And as I can see, I'm on an angle. If I would have tried to force it, I end up breaking it. I should have did this before I put everything in. Come around the other side. If I can see it better, maybe I can get it. Still can't really see it. Maybe. Can't see through this glass. It's tinted. I can drop this some more. Come on, God. Ah. God. Thank you. Alright, now we can put the thermistor wire in. It's going to show me towards like not. You know what I'm saying? Alright. That's it. That's what we missing. What is right there? I feel like I'm missing something. Alright, so that's a wire right there. Got more down here. Like I told you guys, Might find yourself missing some screws. I got a whole bunch of screws down here. What did I forget? There's definitely screws missing right there. Okay. That might be these. Nah, that's too much. Oh, okay. I know exactly what those screws are for. Okay. Screws missing right there. Those are for the hiding cover. I got short screws down here. Those are for the hiding cover. I got a very, very short screw. What else am I missing? What do we have? What do we have? What do we have? Where's this? Yeah, I really don't know. Maybe I just got some extra screws. When I go and check the comments, when I get back in the other side, I will. Anybody who has can let me know. Please let me know. I thought I got everything, but apparently I did. All right. Now put that on. Cover, and these screws that I said that I missed. It's a big screw right there, boy. I feel like I'm missing something. So this is gonna go right here. That's not it. Maybe that wasn't your screw. Know exactly where this was supposed to go. All right, so let me take this off. I know it's, you know what, I'm not even gonna take that off. I'm gonna leave them in there because it's holding pretty decent. I know what screws I mixed it up with, and maybe they need to be longer. If anything fails, I will change it, but I am just going to replace this. Put that on. What are you running into? Replace this with some other screw. That's definitely too long. Here we go. Place them with some M3 4s. And if these are too short, place them with some M3 5s. So M3 4s. Perfect. Want y'all to know I do have extra screws down here. I do not know where they go. I was just checking the hot end. Maybe some came from the old hot end. Maybe, but they're locked up in the heat sink up here. The rest of this stuff, I really do not know. Alright, so looks like everything is cool up here. It's just a bit tight, man. I don't know if it's this. So I'm gonna clean off the X-axis and try and get to some of the Y-axis rods. What we're gonna do with that is there's one big screw here. I do not remember where it came from. But alright, so we're gonna clean these off with alcohol wipes. Kind of dirty, I guess. I don't know if any of those screws I put in were for tension, but I wouldn't think so. I wouldn't think that it would be meant to cause tension on that thing. And from what I remember moving that around, I don't remember this thing having that much tension on it when you're moving it in the X-axis like that. Y-axis is good, but the X-axis is like it's a lot of tension. Like I said, maybe I got something wrong. Who knows? But the best bet, what we'll do is, once we cut this on, we'll do a calibration and make sure that everything is look how dirty that was. Let me see it. And make sure that everything is and yeah, I didn't just put that dirt back on. I just used the other side. Yeah, but do a calibration test, make sure that it has the proper resonance as far as all axes, X, Y, Z axes. If it does, we'll do a test print. Won't do anything too big. We'll do like a benchy or something like that. locked in with this stuff, man. So I said, that when I go back in the office and, you know, take a look at the chat. So before I really need to have something like the chat right here so I can speak to you guys. Or if I'm doing something, you can give me advice. And before I go back, you know what I'm saying, and hear you guys tell me it's no audio in there. After I did a whole 2-hour video, you know what I'm saying, I should learn my lesson from that. But, you know, I get so locked into this stuff that a lot of the times I might not even be looking. If the chat was here, I wouldn't be looking at it. So, this build plate is disgusting. I'm gonna wash that off later. But right now, I do have an extra build plate. Get out that magnet. It'd be good. This K1's been down for a minute. A very, 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 very long time. Maybe a few months now. It'd be good to get this thing back in the lineup. It's definitely, like I told you guys before, it's definitely a reliable printer. Let me see. Get you on the build plate. See my sideways camera. So this is the build plate. I'm going to take the sheet off of it. I don't know if I got any of my secret sauce around, man. Alright, so let me take the sheet off of it. It says apply glue on there. It says please apply glue before print, but don't use the used glue. The glue tends to cake up. A lot of the times I use Aquanet. Aquanet is a very it's a very, very good resource to have as far as 3D printing, because it'll allow like these things, because if something was the printing on here right now, it will probably slip off and you would get a failed print. It allows you to create a glue-like coat that the print will stick to, and then when you're ready to pop off, it'll pop off. Then you got other services where filament loves to stick to, and when you go to take it off, it kind of ruins the print and ruins your build plate. Aquanet creates that, again, it creates that film that it sticks to that, so when you go to break it off the build plate, it's breaking away from like the Aquanet film that it was being built on. So that tends to allow it to come off. You get a smoother sheet. If something sticks, it comes off easily after a while, especially when the sheet cools down a little bit better. What's up, y'all? All right. So I am going to close this. I'll straighten this back up. And I'm going to bring you back. I'm going to bring you guys this way. And hopefully you can see that screen once I get it on. Alright. Right now you can see the picture I took. That's in Columbus Circle. Went to Columbus Circle coming out the subway, took the picture, and redid the art thing with it. So let me plug this thing in so we can get going. We can find out if our printer is back on the market. Right? As soon as I find power wire. It's already off. Let's see what we can disconnect. Wow. That wasn't good. So now I'm gonna turn it on. I'm trying to get you right over it. Improper operation detected last attempt. Let's see if our improper operation is good. Resume. Zoom. Okay, there we go. Alright, we're gonna stop this. We're gonna stop. See how long ago I was printing something on here? Is when we first was doing the linear rails and we had the Y-stop guides. That's what these were. That's when this thing actually fell. Stop printing. Please do not operate. So we know the heat is definitely working. Some visuals of what it's looking like. And maybe from the top, because eventually this glass is going to have to be closed. Put the camera a little closer. Not pausing, guys, just trying to give you two good angles of when we calibrate and when we test. Bringing this camera a little bit closer. gonna let you see this thing on the top. I want to air that one so you can see what's going on with that. All right. Okay, so we're going to settings, network. It might not even be hooked up to the network. It is hooked up to the network. Perfect. Camera. AI function. Okay, it is. Systems. Self-check. Just looking here and see if everything is like it's set up like it was. Alright. That's the network screen. Self-check. That's how we want to oh, forget it. Let's do it. I was looking for something else actually. Hopefully this is cool, like how the A1 was. You can see once it was doing the input shaping, you can actually see the vibrations in the camera. If you're able to do that, then that's cool. So we got about 11 minutes of this. When it's done, and we do a test print, we'll print a Vinci or something, whatever. And we'll get to this Miraco 3D scanner. Now, I've never used a 3D scanner ever. So we're gonna see how user-friendly this thing really is. Like, you know, of course I've been doing my studying, looking up things on it, and hopefully it comes out with just as good as the results that it's giving these guys on like YouTube and on the Revopoint channels and stuff like that. If it's giving you those good results, I'm fine with it. Things, minor little itty bitty things here and there. If I'm making a 3D image of someone and I'm 3D printing something, I can go and make my adjustments in ZBrush. So we're going to see. I'm excited to use it. I'm excited to go. So we'll find out if it's really something to work with. So it's input shaping right now. Yeah, see, you can see it in the camera. So those are the vibrations that are created through the speed, you know, from the starting and stopping and stuff like that. The rings on your prints. That actual vibration is what creates those. What it's doing now is testing the counteractive vibrations in order which to make those things not happen. It does help with speed. It is for speed, but it's for more precision than anything else. So, you know, it's just giving you a counteract of vibration. So if this vibration causes this, we're going to add this vibration which basically mutes that vibration in order to give you a nice, decent looking print. There's something wide open on the side, right? Ah, okay, maybe that's where you connect the LiDAR at, if you were to upgrade this with that. Because I'm seeing a bunch of ports on there that's just open. You know, I'm not understanding why. Like, you know, if a lot of times on these PCB boards, a lot of these ports are being used unless you could do certain upgrades, and that's what those ports are for. And I'm assuming, I'm almost 80% sure that that is for the LiDAR connection. Because these you can't upgrade with LiDAR. I've been looking for it, I haven't seen it. But the K1 Max, of course, does have it. I wasn't even supposed to touch the printer, and I touched it. It says, do not touch the printer during the self-check. What if it popped up like, yo, start over again because you don't listen? So I can't really touch nothing on this table. So it's doing its checks. It's still doing its checks. It's auto leveling now. The input shaping looks like it went pretty good, as you guys can see. Has a check mark by it. This will always watch your first layers. Always watch your first layers, or you will get stuff like this, and you will have to make repairs like this. So always watch your first layers. If you see something that's going wrong, stop it. Stop it. No printer is 100% every single time. It will feel that way, but eventually that printer will fail, and the potential can be catastrophic to your printer. Now, luckily, a lot of these printer parts are not that expensive. I believe this kit was somewhere around like $20, if I'm not mistaken. Anywhere from $20 to $30, which was a good thing, you know. So that repair cost me $20. But say if, you know, as I was going through this repair, you guys could see me kind of stumbling and bumbling a bit, and say if I would have did something else that would have made a catastrophic mistake. So I say all that to say, always watch your first layers. So while this is doing that, I'm gonna go run in the office and check you guys out on the chat, see what's going on. There we go. What's going on, Diggs? By the way, 7. I'm good. I'm good. All right. Let's take a look at. Let's watch the shop. Still doing this thing. Most of the screws on the install were like of course they all were M3 screws, but a lot of the short screws look like M3 by 6s. Mostly all the other ones were M3 by 10s. So you had M3s by 10s, M3 by 6s. The last ones I used when I was closing up when I was putting the cover back on, I pulled out of my own personal stash was M3s by 4s. So yeah, they're all M3 connections. The springs on the actual where the PCB wire is connected going to the main board, the motherboard, those are like the plastic metal, like they eat kind of into the metal. I'm sorry, they eat kind of into the plastic in order to hold the grips. So that's where you put the springs in on the top by the wire, and then you tighten up those actual screws. Type it in chat. Yeah, I thought my mind was picture perfect. So yeah, I know you usually do need to take a bunch of pictures of what you do. I could have swore my mind was picture perfect, but in all actuality, it the memory came back as I was going with it. The memory came back, so that kind of helped out a lot. It was just placing the screws, as I was doing it, as I was consuming the screws, like, things were where they were. Now those other screws that were in place there, I'm pretty sure when I went to straighten up a bit, I just put screws inside of those things. So, but if this thing falls apart while it prints, we'll know. So what we're gonna do is we're gonna go back into the shop. I'm gonna connect some filament and we're gonna run a test. And then after that test, I'm pretty sure this print is ready to go. After that test, then we're gonna go to the unboxing. Let's get to the shop. Here we go. I had to get my trusty Aquanet. Let me spray this. Self check okay. Went to the home. I gotta turn it back on, so you guys can actually see what I'm doing. I'm going to drop this build plate. What's that? One more time. You do with this, take it out of here. Remember, when you put an Aquanet on, take the build plate away from the 3D printer. You do not want to spray any of the rods, any of the linear rods that it rides on. It would make it sticky, and over time, eventually cause movement issues. So I tend to take it and spray it away. Make sure there's a good layer on there. Boom, done. On there. So I usually always close my my K1 because I leave the top open unless I put it on there and I'm printing higher temperature things. So let's see what we're almost out of. We're almost out of this purple, this gray purple, matte gray purple. So we can take that. See if I can still load this thing without looking. First of all, this isn't a bamboo lab. I don't really think it cuts itself, so you want to cut it at a 45-degree angle. Creality printers cut them at a 45-degree angle. I'm not sure what they do on their other ones, so we're gonna put that on. Find the tubing. Alright. Not even locked in right now. Run it through. Like how I would load the oh no! Alright. Load it. You guys, in case you guys don't know how to load this thing, I'm actually wrong the way I'm doing it. I'll lift this up and show you. Pretty sure if you're printing on here, you actually know what you're doing as far as printing goes. Let me lock in on that. Alright, so with this, usually the tubing, PFT tube or whatever type of tubing, this usually is connected in here, right there, and it has a blue clip on there in order to stop this, because once this goes down and it comes up, it grips on the side of this tubing and doesn't allow it to move out of place anymore. The blue tag, which is like the lock, goes underneath here, and that stops it from going. So this will usually be connected. So everything that I'm about to show you with this filament naked usually happens behind this tubing. All right. So make sure your lock, this is the lock switch, is set to unlock. Mine is already set. If it was locked, it would be there. Unlock it, push it over. So we're going to push the filament through. It's unlocked. Get it past the extruder gears. I usually like to make sure that it gets down into the actual hole. And see, here we go with that not being able to. There we go. It's all the way through now. Okay, so it's in there, right? So we're gonna push down. Usually, I do not know where that thing is at. Maybe I got a bunch of them downstairs in the official workshop. I got a bunch of them down there. So I'll just put it on, lock that in position, put this in the lock position, and you're ready to go. So what we're gonna do is we're gonna load the filament. I'm gonna open this up and let you see it. I'm gonna actually take you off of this screen and let you see it. All right. So now what we're going to do is we're going to just load, we're going to extrude some filament, and that's how we load it. So right now the nozzle is at 36. And everybody knows with the K1s and all of these, I forgot the term they use for them, like basically out the box printers. They heat up pretty fast. So, and then you know, once you get a new 3D printer, I mean, once you get a new nozzle, you always smell like that coating or whatever grease was on it, whatever coating was on the nozzle, you smell it burn. So it's extruding now. Let me see if I feel anything coming through. It's definitely pulling. There you go. There you go. Alright, so it's done extruding. And there it is. So what I'm gonna do right now is, we got our Aquanet on there. File. I'm gonna find the benchy that came on this 3D printer, the original one, where they were trying to break records. That's what they call them, flagship. The original, you know, like flagship printers, the printers that are supposed to be ready to go. So here we go. Let's see if it's still high quality prints. And for those who didn't know, I never even realized that. I've known for a while now, but when I originally got this, that this is how it cleans the nozzle. So when it's doing this, it's actually just wiping the nozzle, which initially I used to think like purge blocks and things like that were like unnecessary. I believe like most prints should have a purge block to them. You know, a lot of times, you know, some of these prints get little bits and pieces because, like, say if you're doing a time lapse video and then it goes away, like you're doing a time lapse where the print nozzle stays to one side or in one particular spot to make it look like it just rises up, like, or say if it not in the middle because it'll be dripping in the middle, but if it's off to the side, before it comes back to that print, there should be some type of purge block right there in order not to keep adding little boogers to your print. So this, you know, this is kind of cool that it cleans the nozzle off. You don't always have to do it every once in a while with like a metal brush or anything. Trust me, it's just leveling. It does the 4 corners instead of all what's that, 16 spots now? The 4 corners in the middle. Here we go, nozzle heats up and it does this crazy I'm trying to break the record thing. Shout out to Sid the Wing. It's an Axolotl Dragon. Or Axolotl Dragon, however you say the word. Super fast K1 at its best, because it obviously they wanted to ship it with something on there that was going to print this fast. They must have made a tweak in the firmware with this 3D printer, because I got the first ones that came, the K1s that first came out, and I went to print one of these benchies. Now, it kept failing. It kept failing and failing. So when I reached out to Creality, I asked them, why did it keep failing my 15-minute benchy? So they told me, you have to use high-speed PLA. So I said, cool. I used high-speed PLA, and it still failed. Like, one more time. Then I used it again, and it actually printed well. The benchy printed well. But then at one point in time, I said, well, let me try using regular filament again. Regular PLA filament again. And it printed well. So there must have been some tweak inside of the firmware, because it might have actually been moving, or they didn't have the flow, the tempo flow set up correctly inside of that actual file, maybe. I don't know. But it was failing. Even the one where it shows the full, I think 500 second speed, that one was failing. So yeah, they made a tweak to it, because now it's like every time I print this speed benchy is flawless, and it doesn't matter really, as long as you're not using anything outside of PLA. I've never tried it with PETG. I've never tried it with like ABS or ASA or TPU for that matter. I haven't never even put TPU in this machine. So no, I'm lying. I have put TPU on this machine. I haven't put TPU in the Bamboo Labs X1C. Just inside the AMS unit. I've never done that. Yes, I have compared the X1C to the K1. The X1C is still faster. K1 just starts to print. It starts to print. Like it does those four corners and then it goes. The X1C does its usual 16 points. Whatever point is in right, it'll tap it a couple times. It does the first layer check, LiDAR. It does all of that, and then it goes, and eventually it catches up to the K1. If not, beats it sometimes. With its speed benchy test setup. But it's not by much at all. And for anybody who's watching this that may watch it because, you know, I'm familiar to them, or, you know, you're not into 3D printing, but you see this stuff, this isn't fast forward speed. This is how fast this printer is moving. So anybody in the world of 3D printing, there's so many printers that move up to this speed now that, you know, it's not shocking to us, but it used to be. But I still like to watch it because it's still amazing. It's not shocking, but it's amazing. I'm even looking at it on the video, and this looks like almost like it's sped up. And yes, I still plan on building the Ender NG. Tell you what, boy, that's some amazing 3D printing right there, man. Especially when it gets like that. I think it passed the spot where it just goes crazy because it's like it has infill and it's already, you know, it's just printing the top surface of a next wall layer and it just goes. Yo, that always gets me, man. That always wants me to pull somebody in the room like, look, look, look. So yeah, and that kit I put on it was the quick change kit. So if I need to replace nozzles, those nozzles are expensive. You know, you can get a pack of regular nozzles for like, I think it's like 10 in the pack for like $10 sometimes, anywhere from $10 to $15. I think one of these nozzles costs around like $6 or $7. For those who don't know, Pure XY printers are always the fastest printers. Like even Creality before the K1, they had their 5 series, which was somewhat of Pure XY, but it wasn't belt driven. It's still like wheel driven, but the belt driven ones that move along like these roll. I don't know if you can see it. You can't see it, but the rollers on the side, and they just have the belt. These are very quick printers. They have strong motors running the X and Y, yeah, the X and Y axis. And as far as like I was saying, like if you didn't know, a lot of people know, you know, like me studying 3D printing stuff, I picked up the Aquanet tip along the way. Look how it sticks. They're telling you to put glue stick down because it initially wouldn't stick onto that. That's a brand new build plate and it's sticking perfect. I know it created an auto bridge, but if a print's not sticking to a build plate, it's not sticking to a build plate. Even if you got that auto bridge up there sometimes. No, I'm sorry, not bridge, but brim, auto brim. Stringing, and this is old filament too. And I know some people ask, why do people print benchies first? Like, why do people always print benchies? My caliber, I got to put new batteries in it. I will show you. But there is, like, these benchies have specific measurements to them that will let you know if your 3D printer is calculated. Maybe I can spit off the website, and when I get back into the office, I'll actually go to the website where it shows you those specific measurements. Not only that, does it show you the measurements like this, let you know if your printer's over expanding filament, under expanding filament, over extruding, under extruding. It also has like the bridging, like the top of the benchy, the roof of the benchy. There's certain parts where the bridging is tested, so you can test your fan speeds, if your fan's too high, fan's too low. Right here at the I guess the hole, not the hole, yeah, the hole in the front. If you look at it, the way it's shaped, if it's kind of like bent in too much, you'll know if if your printer's moving too fast and your fan speed can't keep up with cooling your filament as it's being melted. Right here, within the middle of the benchy, if you can see, like, the doorway, the back and forth, that's for extrusion and stringing, to let you know if your extraction and retraction is working well, to let you know if you have enough extraction, and let you know if you have too much retraction. That's what the actual doorway and the windows are for. Right here is where it's going to start to test out the bridging at the top, where it creates the roof. You'll see it slow down somewhat in order to cool the filament as it bridges. Like, there's a bunch of tests in one benchy. That's the reason why people should be printing. Like right here, this is the bridging. Even though it looked fast, that was slower than how it's moving now. So if people are printing benches, you want to print them and then do the calibration tests that are on the website. Like, this speed is amazing to me sometimes. Almost done. Even that's the test up there where it's finishing up at. And 3D printers are liars too. I don't know if you can see. I want you to see when it finished, but on the screen it says a 17-minute benchy. It says 17 minutes now, and it was still at like 98%. So no, it's not exactly 17 minutes. And there it is. All right. So while the build plate is cooling off, I'm gonna wait till it cools off in order for me to pop that benchy off. The K1 is back. The K1 is back. That's a good thing. So like I said, take this off. Take it off the plate, take it off the build plate itself, remove it from the magnet, the heat's still on there. Popping it off now. Alright, so you didn't know, see if I can get it in this camera, it's better. I'll get you to see it. Anyway, this is a test too. That first layer, if you can read that, first layer is pretty good. I like the first layer on here, but it's not perfect. Those words aren't perfect, and you can't really see it. What I'm talking about, maybe down there, maybe, I don't know. But this brim could be another test. 3D bench. I mean, benchies don't usually print with brims. But if it comes off easy, that means it's accurate to a certain point. A little bit left on there, so it's pretty good. The hole is good. This is what I was showing you about this. If it's indented in too much right there, your printer is moving too fast for your filament to be cool, so you might have to turn down your speed a little bit. This right here has to do, so I'm gonna get this back so you guys can see it better. Alright, this right here, back and forth right here, has to do with the extrusion. You're leaving stringing, maybe you gotta turn up your retraction a bit. These measurements in here along these walls, you have to take those, go to the Benchy website, compare them to what you get. The actual top shoot is a measurement, you know, here at the base and at the actual tip, because what this did was basically climb out to the side. If it heats well enough, you got a pretty decent you know, calibration. This right here, we got, it looks like we got a slight hole right there. Zoomed in on my hand. That's fine. Looks like we got a slight hole right there, which means it could be over extruding. See these waves right here? That's what the input shaping test was testing against, so that it can have its countermeasures in order to stop that. Apparently, if it didn't do that, these would be way worse. You would even see like an echo coming off of this, the hole in the hull. Sort of like right there, but it would have been worse. Venti is pretty decent. Like if you look at this part of the hole, you always got some spacing, and that's because like you got a lot of infill right here, and then it goes up, it gets kind of hollow around there. You see the base and stuff like that, so there's no more like infill, and it actually started building up on the sides right here. That's why you got more of the layer lines in there. Got a bit of a hole right there. I mean, it's not perfect, but it is a good benchy. Definitely is a good, beautiful benchy. Not perfect at all, but I like it. I dig it, and I love this 3D printer. I love this 3D printer. Nothing's perfect. None of these are perfect unless you calibrate to the T. And then once you print a few things, you calibrate to the T. Then you print, then you get a couple good perfect prints. And you know, that's what these 3D printers are all about. You know, just making sure the maintenance is so important on these things. All right, now that we got our K1 up and running, turn that off. All right, now that we got our K1 up and running, we can get to this thing right here, the Miraco 3D scanner. That's the Pro, actually. That is the Pro. It don't say it on the box, but this is the actual Pro. Let me move these cameras. Let me get this camera back some. I'm going to turn this K1 off, and I'm going to move it back in its production location in the official shop. So, lock this in. Alright, thank you K1 for coming back online. You know I love you. Sorry I gotta turn you off right now and tease you like that, but I gotta turn you off. Alright, so lock K1 is off. It's a lock because it's a female and I love her. Alright. That, put this back. I'm sorry you guys get to see me clean up a little bit, but I want to make room for this Miraco. So we're gonna go back. I'll take you back from there. Put this up. See how fast I can do this. I'm not a quick cleaner because I have ADHD. I'll get lost in the sauce somewhere. Can't wait till I can officially put these on with you guys. Maybe that'll be soon. Alright, let's put this up. Alright. Every time you get something new with 3D printing, you get more Allen wrenches. Anybody who's a super 3D printing enthusiast, get these things for free. They must be the Allen wrench king in their family. Go talk to D-Kel. I know he got some Allen wrenches. Now we do have that. I'm gonna leave that on the desk because I'm gonna do that. That's the ceramic block heater for the that's one thermal grease. Put the thermal grease on. I'm gonna keep that around. I'm gonna probably have to do that. Usually the thermal grease is when you connect that sleeve. That sleeve was already connected, but I didn't check it. You want to check that type of stuff because you definitely need that thermal grease on the actual on these ceramic hot ends. Throwing things in the garbage, people. There's old hot ends going in there too. I'm sorry. Even though you were my mistake, I won't forget you. Bear with me, good people. I'm still straightening up a bit to get to the Miraco. This too. This is a motherboard. I gotta get a pin out on there to redo some clipper firmware for the Solo. All right. Okay. So we're gonna put this down and we're gonna plug this thing. Okay. Ooh, a lot going on over here. Alright, I think this is clean enough, people. Here we go. Now, it initially came in a box that I thought was just packaging, but that was hold on, give me 1 second. I'm sorry. Alright, so initially it came in a box. I'm telling you, it was, I thought it was just packaging, but it was the initial box. I know this, I said this is the unboxing, but it came in a box, slid it out, this is what you got. So, you missed that part, I'm sorry, but the rest of this is a genuine unboxing. I didn't want to touch it until you guys saw it. So, let's get a camera on here. Which camera? Right, I like this camera better. I always do. It's the more up to date one. The one you're looking at me on now is the officially the up to date one, but that's my Sony. All right, so this right here. So let me go. Just want to change source. I just want you guys be able to see this part of it and from the top as well. Screw back. Three. All right. So this right here is the box. Turn it around. All right. Nice 3D scanner. Looks like a camera. Okay. Boom. Unbox, kid. All right. What do we have here? We got a little pouch, a little ammo patch. See what's going on in here. Alright. Nice. Nice. Definitely to hold it. Oh, and it comes with a turntable. That's good. That's good. Comes with a sex whip. All right. This is the actual, I guess it's like a wrist strap. It's a lint-free cleaner. This is a, I guess a HDMI converter to go out if you want to see it on screen. Feed it into your computer through a device capture card. Stand, of course. I think we'll be using this, as I saw on online. They give you this little model for you to scan. I think it's set up correctly, like just the lining on the thing is set up correctly for it to scan. All right, this is the USB drive. USB-C to regular USB drive in order to connect it to the computer. And you have a USB-C to USB-A converter. Okay. USB-C to USB-A converter. All right, that was all the packaging inside of here. Nothing else. So I'm gonna put this stuff back in here. Maybe not these. Yeah, I'm gonna leave these out, but I'm gonna put that stuff back in there. All right. Go back to the box we were just at. All right. Now, like I told you before, like I said to you guys, I'm not familiar with 3D scanning, but I'm pretty sure that this is like a basis, and from what I've seen online, for the scanner to read, to know that this is the platform and not the actual object to be scanned. Like whatever's in here is being scanned, so it doesn't confuse the platform with the object. If I'm not mistaken, these are targets to a certain extent. Same goes with these. These are targets. These are pillable and targets for things like maybe if you want to 3D scan a bumper on a car, or you know, the console to your car, because you want to design something new and 3D print something for your car. You will place these stickers on there so that it can read the object that's being 3D scanned. You will put it on that, if I'm not mistaken. So that's more of that stuff. This is the same thing. Marker topper used in marker mode to assist in scanning featureless objects placed on turntable or tabletop. So I guess this is the same thing I was saying. Like it's a separator to let the scanner know what's going on. That's the base, and this thing that's sitting on top of here is what you're scanning. Just a quick start guide. Does not look quick unless there's a bunch of different languages in there. There might be a few different languages. So, but it doesn't look quick. Things about 3/16 thick. All right. Let's get to it. Looks like we're getting down to the bare bones. Power adapter. 2 USB-C ports on the power adapter. You know what I'm saying? It looks like something you buy from Amazon when you don't have your Apple adapter anymore. That's what people use Apple. I use Apple. Blue text. Okay. I thought that was the computer connection cord. I guess this is just the charger. USB-C to USB-C wire. Alright. Guess this is a warranty card. Warranty card. This is the model I was telling you about. I guess that everybody uses to test. What I've been studying from 3D scanning, what's been being said is you want to spray the 3D scanner coat is like this, usually like this powdery feel. Like, I don't know if it's a white, if it's like a white washable spray paint chalky type of deal, but it gives it that feel. This has that feel, like I guess like it's made to be 3D scanned, you know. So this is going to give you the results at the optimal level of 3D scanning. So that's why, you know, a lot of people have been having success with this thing. I've seen people who've had success with anything that they scan with this 3D scanner. That's why, you know, I actually purchased it. And here we go. Meat and potatoes, baby. This is the actual Revopoint Miraco Pro 3D scanner. I mean, I get a whole bunch of different feels when I hold this thing. Pause. But it feels like a DSLR. It also feels like a video game console, but it's pretty nice. It's very comfortable. Very comfortable. It makes you want to do something, you know. So it's very, very comfortable. It has the flip screen, so if you 3D scanning your own face, like, you know. See, if I wanted to get a mesh of myself, you know, I don't have G.I. Joe arms. I can't go all the way back here, but I can go far enough back, you know. So, yeah, that's nice. Before I turn this thing on, I want to look at the quick start guide just to make sure that, you know, I don't have to have it on the charger and stuff like that. I want to make sure that I'm not blowing this thing out as soon as I start it up. So there's a few things. I'm gonna try and stay organized. Like I told you guys, I have ADHD, so whenever I get involved in something, things go everywhere, and I'm like a magic magician. They'll disappear when I really start to look for them. So I'm gonna keep everything out here that I need, which is the little guy right here, the turntable, and actually maybe those wires for the turntable were for this right here, because this is actually plug and play, not battery operated. So I'm gonna keep the turntable out. Oh, see, of course I'm gonna keep the Revo out, the statue, the power cords, the stand. I'm gonna use that for the stand, and I'm going to keep this topper out for when we 3D scan. The rest I'm going to put back in the box. And if I'm going to be using this thing, And this bag is pretty. But of course you spend a couple dollars with this thing. This thing was like $1,400. So, whatever you need, you can place in this bag. So, the hand strap, I'm gonna place in that bag or by the bedside. I don't need these. I have a bunch of these. This is. I don't know. Well, this is how you convert the video. I have those, and if I need it, I know it's in there. All right. This is more than likely power for the turntable. That will go in this pocket. The lint-free cleaner and this converter I'll put in here. Of course, the charger I'll leave out. But the rest of these Target stickers and applications I'm going to put in here. All right, so I'm going to close this up now for the meantime and put that up. All right, these guys out here, remember, told them to check the quick guide. So in the quick start guide, it gives you a so you guys can see what I'm saying. Hopefully, it gives you a layout of the 3D scanner, right? It gives you everything that's in there. USB Type C to USB Type C. It's obviously for the scanner. The power block, it's obviously for the scanner. Turntable, mini turntable. Vertical near mode calibration board. I may have to calibrate it with that. I may have to take that back out. I didn't know that was a calibration board. Scanner bag, wrist strap, tripod, markers, magic mat, cleaning cloth, sample bus, quick start guide, certificate and warranty card, Note Macro Pro package also includes FAR mode, calibration board by large calibration board sheet by 1, and a USB Type C to HDMI adapter. Okay. For the first use, please charge the Miraco to more than 60%. So that's what we need to do, is charge it to 60%. More than 60%. Long press the power button in 5 seconds. Power button should be on the side. Yep, power button's right there. Alright, give me English. Connect to a Wi-Fi for project transfers and software update notifications. Yeah, we'll do all that. And what I might do is when I turn this thing on, let you guys see the screen. Alright, helpful screens, one finger swipe, pinch, zoom, all that type of stuff. Scans, read the instructions, scan settings, exposures on macro, setting up a scanning environment. For the first scan, it is recommended to scan the sample bus, including in the package. Find the tabletop free of any clutter, put the sample bus on the turntable, and ensure no unwanted objects are within the scanning area. Select the scanning mode. Select the continuous and near modes to scan the sample bus is recommended. Alright. Scan settings before scanning. Scan settings. The recommended scan settings for sample bus are high accuracy, feature, general, and color toggled off. So I gotta Remember that. High accuracy, feature, general, and color toggle off. Alright? This setup right here. See that? The way they're, I don't know if you can see that, the way their grammar is making it seem that all of these have to be toggled off. So it says the recommended scan settings for sample bust are high accuracy, feature, general, and color toggled off. But in all actuality, you got to set your accuracy on high, alignment on feature, object type on general, and color toggle off. It's also recommended to turn base removal off. Depth camera's exposure adjustments. It's recommended to disable auto exposure for depth cameras and manually adjust the exposure bar until these are minimal red or blue areas in the preview. And I can't see what they're talking about. This is a black and white book. I don't know what's red and what's blue. But correct exposure looks like this. Underexposure is dark, overexposure is bright. Just like in a regular camera. Scan distance adjustment. Okay, so that's using the distance adjustment. Keep it in the green, basically. Keep it in the green. Tap the record button to start. Tap it again to pause as needed. Complete scan. Tap the complete button, which is a check mark. After completing the scan, tap the model icon to edit it. That's this icon right here. One tap edit. Matter of fact, wish I could see the chat, because one of you many people out there that's smarter than me would have told me, D-Kel, why you reading that? Won't you charge it to 60%? So while I'm reading this, won't I charge it to 60%? Makes sense, right? Alrighty. Oh, my legs. Yesterday was leg day, people. Yesterday was leg day. And they hurt. Alright, let me take this off and use this over here. Alright. Let's get that charged up. And what I will do is, let's see where the converter comes out at. Like I said, once I get going on this thing, I want you guys to see the screen too. So I will be converting the screen over to online to stream it. But for right now, since it's got me going, I'm just gonna hit start. I'm just gonna give it wants you to probably pick the Wi-Fi, which I don't want you guys seeing anyway. I'm putting in my password. Alright. Put my password in on this thing. I have to do so much stuff out loud, I almost started telling you guys my Wi-Fi password. Let's join it. Okay. Set time zone manually. Okay. Estados Unidos. Estados Unidos. Time zone. It's always, let me see. This thing is charging. It's always represented by NY. Okay. Please carefully read the following proceedings. Speed read, y'all. Ooh, I read it. Alright, so I guess this gives a whole description on how to set things up. Single shot mode, that's when you do it. You move it around and take single shots. Bam, 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 bam. Alright. Project. About the project. Multiple ones. Post-processing. Alright, we're at 72%. So what I'm going to do is I'm going to take out this converter. Let's go. Alright. Come on. And I never opened that other box, did I? Alright, I'll open that after we get done doing this. It tells you what's on the box right there. It's it's more of this stuff, more calibration. There's more calibration stuff like this. Alright, so I said I wanted this right here, right? So I only got a little bit more time on the stream with you guys. Love being with you. Alright, let me put this back in. We read our book. I might need to refer to it, like I said. So you guys can see right here, this is the other box that came with it. Which, like I said, I'm pretty sure is more just calibration things for, you know, once you put your calibration stickers on certain things, you're going to need more. So I'm pretty sure that's what this is, like a handful of this stuff. So this is the large calibration board that they were talking about. The Pro comes with the large board, like calibration for 3D scanning. So if I wanted to set this up and calibrate it for large 3D scanning, I can do that with this board. That's what this actually is. This is, I'm pretty sure it's a bag for it. We'll go in here. We're gonna keep this thing in the box. We'll go in depth more. This is actually, this 3D scanner is actually for us to provide a newer service for, you know, like when we do our table events, to, you know, be able to 3D scan an actual individual and then ship them a 3D model of themselves. So like I said, if it gives us the scans that people have been getting, and I know nothing's perfect, but if it gives the scans that people have been getting, that's enough. That is enough for me in order to put it in ZBrush and do what I gotta do with it. So that's 70%. He said at least get it to 60, right? We're at 60. All right. Next. But you guys see the screen what I'm working with. Start, right? Okay. So next, select scan settings before scanning. Next, type switch. Scan small objects using near mode, far mode for large objects. Swipe down from the top of the screen for more functions. Alright. So we're going to keep it continuous mode. Let's go here. They said keep it accuracy high for this scan. Keep accuracy high, alignment and feature, general object type at general and color toggle off. Okay. Alright. Shit. So put this out the way. I'm trying to think, do I need a longer HDMI wire? I think so. You see what I'm saying? You see how I was picking this up like almost immediately? I moved it. It's too close now. Oh, no, that was done right. So it's picking it up almost immediately. That's because it has that texture to it. Well, let's get my hand though. Look at that. Look at that. Look at that. Peace. All right. So, yeah, let me get some more HDMI wire. The screen is going to cut a little bit, but I honestly don't want to trip over that thing, and I want it to be free moving as well. So give me 1 second. Could have swore I had more 8K wire. Oh yeah, it's right here. Didn't even have to go anywhere for it. Alright, just a little bit more wire. It's not a lot. So I'm going to give you guys back to this camera. Fine. Give me some distance on this wire a bit. Alright, there we go. Now it's not holding on by the hairs of his chinny chin chin. So you got the I thought I was going to need this, but apparently that looks pretty good, man. That looks good. So I'm not going to do the scan like, you know, I'm a Hollywood director thing. I'm actually going to put this in the middle of the table. So that's a good distance. And that's a good distance. Maybe back some more. Far. Good. right? Alright, so it's ready to go with that. I'm forgetting something. Oh. We gotta get this thing going. I hope it's enough wire for me to get to this. So we're going to keep it continuous. Hit the record button. Once this thing, then you know, start to spin this thing. And what wire do I have right there? That camera. Alright. Let's see, do I have another long camera here? Wire. Swore the other one was in there, but I'm gonna use that. This wire isn't long enough, but I do have another long wire. One more time, good people, but I know exactly where this one is. Alright, there we go. So, I'm gonna plug that in here. Just give our turntable a little power, give it a little power. Are you serious? Now, the converter. This isn't going to work. Okay. My apologies, people. I'm looking for a workaround. There's always a workaround. Alright, here's the workaround. This thing is white. Screen went off. There we go. See, it's going to pick up that wire. And we don't want it to pick up that wire. But there's something we can do. Which wire is this? It's your wire. What I'm having, the issue I'm having is this wire is way too short, but it's a black wire. You need this in order for it not to pick up the you need this for it not to pick up that white wire, because if you guys can see in that screen, it sees that wire. because that wire is a white chalky wire that's easy for it to pick up. Now I'm looking to see if I'm connected to anything with this wire that I can eventually let go. So you are connected to this camera, which I'm not using that camera right now, so this camera will come off. Think, yes, this camera is going to come off, and we will use this power adapter for this camera. For this right there. There we are. Make sure it locks into place. Alright, now that is on. That is on. Is it still good? Is it still picking up? Or is it too far? Trying to get it. Saying it's excellent, right? All this weight from this wire. Let's move this wire up. There we go. Put you in the middle. It says good, right? So we're gonna hit record. Boom. It's recording. Turn this thing on. There we go. I don't even know if it sees it. It's looking at the damn door, isn't it? Stop. Close that. Confirm model deletion. Delete. Doesn't even see that thing. There you go. Now, record. Sees all that other stuff too, right? That's what it's picking up. I'm gonna cancel that as well. It's picking up this Revo box. And what else? Something on the table, right? Ooh. Strong, man. Like, I can't even stop it. Alright. Trying to get it to where. Didn't they just say it was excellent before? I could see it. It looks good. That's. Where's the excellent at, man? I'm looking for excellent. Oh, that's why. Perfect. Alright, so we're going to hit. Let this thing start spinning. Make sure we still excellent. Yep. Go ahead, record on it. That's crazy. Alright, so I saw, like, alright, so that's high feature, right? And that's getting both sides. So if I pause this thing, right? Go like this, does that get the bottom? Crazy. It does get the bottom. Alright, so I'm gonna hit check, right? Tap to process the model. It's the model processor. Or is that it? Alright, so it says to tap to enter the hub. Okay. Tap to process the model with the user settings and fusion, whatever. Tap to process the model manually. Close. So one tab at it, let's hit that. Let's get details. Let's hit OK. It says about 6 minutes on them. So technically, when we get done, we should have something that looks very much like this. So I wanted to see if I laid it on the side, will it process it to the point where it takes, it's on the bottom, it's on the side, it's like the more angles you 3D scan something, that is it going to put it together and make something official, you know. So hopefully it did. Hopefully it did. And then what I'll do is, whatever it comes up with, once we'll see it together. You know, it's nothing but a few minutes. It's like halfway through the process. So whatever it comes up with, 3D print and do the comparison. We'll do it together. You know, so. All right, let's see what it got going on. Let's go back in here. It looks like I might have messed it up. I did. Some raw data. Fused. Tap to use. That's fused data. Alright, so we don't want to play around with it. I really don't. I think you can do that, but scan. I think you can actually do that, but I'm not sure. So I'm just gonna do. You know, I'm no professional, I'm no pro or nothing like that. So I'm just gonna do what it's telling me to do. Right? Hit. Why is this thing like not sure what it's doing? Record clockwise. Ah man, stop. Cancel that. Delete. Got my hand in there, man. We'll let it rock like this. Boom, boom, boom. Boom, 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 boom. So it's high feature channel. And I am going to hit, once it gets back on his face, check. So we gotta hit model. Let's see what we about. Let's see what we do. What is what? So I'm guessing fusion is what I tried to do last time. I'm gonna do one tap, detail. Okay. I think fusion is what I try to do. You gotta fuse the pieces together in order to, from different angles, in order to get what you want. Gotta read more on it. Hip it to the hip, top, you don't stop. About to that bang. Let's give it a wee rock. Let's go we do. Well, guess what? No matter what, we love you because of the rock and your roll. Yeah, no, my soul, that you got rock. We are 101 years old. So we're about halfway through. It's coming up in the background, as you guys can see. All right, applied successfully. Let's see what we got here. You see what I'm saying? Like it's still open because it didn't get that bottom. You don't have under his eye. Empty in there. I mean, I would try it with, I would try it a bunch of different times. So I guess now we hit mesh, we hit fusion, isolate, overlap protection, smooth, fusion. Because as you doing it yourself with some mesh. Tech. Alright. What's texture? No texture because it didn't have any color to it. Alright. So on page 2. So let me see fusion real quick. Overlap and texture. Isolation. Okay. I want to see if Fusion notices the 2 scans that I made, because it seemed like that in the scanner, but it seemed like I let it run too long, and it made an adjustment to make it look like some warped stuff. But initially it showed as if the top was on the Y and then it flipped to the X axis. So and I do have the camera module at far. They said I should have it at close. I'm looking at that right there. If you can see in the upper left part of the screen, it's showing me my settings. He said I should have it at close, but I have it at far. I'm sorry for that earlier. I didn't show the sizes to those screws, but like I said, most of the screws on that K1 were 3 mil. The shorter ones were around like 3 by 6 mils. See, this isn't cool. Like, I'm going back. Display last model. So alright, so I'm guessing with this, you get that right upper button. Ensure your PC and scanner are connected to the same LAN. Click File, import from Miraco Wireless Transfer and Revopoint 5 on your PC. Enter the display verification code to Miraco input field for project scanner. So this is how you would do it, or you will come over here to USB cable, connect it to your computer, put it in there, put it in somewhere like ZBrush, close it up, 3D print it, which I will do. Alright, meet you guys over in the office. All right, people. Oh, you got me. Try to line up the camera. All right, people. Thanks for coming out and rocking. What we are going to do is we're going to before I go, I'm about to leave in a few seconds. I will go to the benchy. I'm gonna go to the benchy page so you guys can actually see what the reason where you can go in order to get your benchies and stuff like that. Let me close some of this stuff. I don't mean to brag. I don't mean to boast. All right, let me close some of these pages. All right, let me let you see my screen. All right. So what we'll do is, let me make sure my mic is right on the screen. You guys are going to see a bunch of me's. I just want to make sure that you can hear me. Yep, you can hear me. So, all right, cool. All right, so where you want to go? Let me see. I'm going to Google it myself. Benchy, Rome keyboard. Bunch of computers around here. Benchy.com. There we go. So this is the benchy page in which you want to use it for. Now you look through here. Let's see. Zeiss, and why is it a popular 3D teaching tech? We don't need the video. All right, here we go. Test. Quick test of vectoring online. Looking for the actual 3D benchy calibrations. I'm sure it's up here. Hold on. Material tests, software. 3D benchy calibration test. There we go. It was in that website. I just couldn't find it. So when you actually on a 3D benchy, the reason people print them or are supposed to print them, they're not just toys. They're not like just for the amusement. Even though they look great, they, you know what I'm saying, they give you a sense of accomplishment when you first start 3D printing that I printed this. But it's actually a torture test. It's actually one of the toughest performance, on the tougher side of performance for your 3D printer. And if they perform it well, then your 3D printer is capable of performing well. It doesn't mean that your 3D printer is the best 3D printer. It just means that it's capable of printing things well and smaller things. So, you know, on the bridge, on the roof, this, like I told you, this was about bridging to see how well your 3D printer can take it. If you roll the benchy upside down and looked under here, like rolled it and looked under here where this bridge forms at, see how much that the filament is hanging off of there. If it's barely not hanging, the 3D printer is great. It's at great speed. It's melting the way it's supposed to melt, and it's bridging correctly. If it's hanging, then it might be printing too fast. It might be too hot. You got to do some fan adjustments. You got to do, you know what I'm saying? You got to do whatever you got to do to calibrate it. Then, you know, you get your calipers out. You get some of these digital calipers or whatever you use to measure. And the top of the roof should be 23 millimeters from this point to this point, almost exactly. Now, you could be off by a few points here and there, like it could be 2.98 or something, or 3.04, and that's fine. You know what I'm saying? But once you start climbing higher and higher, you either know if you got too much filament or you got too little filament. So it's either over extruding or under extruding. It's over expanding or under expanding. It's not contracting enough. I mean, it's not retracting enough, or it's extruding too much. You know what I'm saying? So retraction and extrusion and retraction. All right. So you got your chimney roundness. Diameter of this hole should be 3 millimeter. Diameter of the outside should be 7 millimeter. The depth of this roof should be the depth from top to bottom should be 11 millimeters. Inside of the hole, if I'm not mistaken. All right, 11 millimeters, roughly just under half inch. 60 millimeters on the whole benchy, from back to front, 60 millimeters. On the side, 31 millimeters. From the top of the smokestack to the bottom, 48 millimeters. From the back hatch down to the bottom, 15.5 millimeters. Measure in millimeters. They're a bit more exact and easier to add and subtract. So from point of the back hatch to where the door is at, whatever, should be from here to here, should be 10.81 millimeters. Outside the outside, 12 millimeters. This inside box right here, 7, 9 on this inside, 9 millimeters going up and down right here, 8 millimeters this inside the box right here. All right, this hole, 4 millimeters in diameter. The thickness coming off here should be 0.3 millimeters coming off the side of the hole out the hole. The bridge for the front wide windows, these are the measurements here. The back windows, these are all diameter measurements, and as far as it extrudes out, it's 0.3. The hole should be at 40 degrees from the point where it touches a flat surface to where it comes up and starts to bend out. The bridge roof, 5.5 degrees from the bottom of the bridge to the top of the bridge, and whatever you get right there. Our benchy didn't have this on the back, so I didn't see it, but its accuracy for how far it can come out is 0.1 millimeter. But yeah, 3dbenchy.com/dimensions. That's how you will test out your actual benchy. All right. So with that being said, time to wrap it up. Thank you for rocking with me. Thank you for opening up the Revopoint Miraco Pro. We got a 3D scan in there. We got work to do with that. Rocking with me on the K1. We got that back up and running. So that's a benefit. Great thing, back in horse mode. So thank you so much. Thank you. See you in the next video. Happy